Latitude. As we know, latitude of a particular location plays a major role in the solar radiation received at that particular location. So latitude is represented by 5, the symbol, and latitude is defined as the location on the Earth's surface in which the angle made by a radial line joining the given location to the center of the Earth with its projection on the equator plane. As you can see, the Earth's figure, the North Pole and South Pole with respect to the equator, and the position of the observer with respect to the position on the Earth's surface. Solar time. It is the estimation of the passage of time with reference to the position of the sun in the sky. There is apparent solar time and the mean solar time. Mean solar time is also called the standard time. Standard time is LS, which is the local time, plus 4 into L location, that is the latitude of the location, minus standard meridian latitude, that is LSTM, plus E. E is the equation of time. LSTM is the standard meridian for the local time zone, and LLOC is the longitude of the location in question. The particular formula of E gives you the equation of time in minutes. Here B equals to n minus 1 into 360 by 365. Here n is the day of the year. So if the particular calculation is done on January 10th, n equals to 10. Our angle omega is the angle through which the Earth must turn to bring the meridian of the observer directly in line with the sun's rays. It is the angular displacement of the Earth towards east or west of local meridian. This happens due to the rotation of the Earth on its axis. As you can see, the hour angle changes as the day progresses from 6 a.m. till 6 p.m. and it is 0 degrees at solar noon, that is 12 p.m. So 1 hour is 15 degrees of rotation. At solar noon, the sun's rays are in line with the local meridian. Omega is negative in the forenoon while omega is positive in the afternoon. So omega can be calculated by the formula solar time minus 12 in hours into 15 degrees. Solar declination angle. It is the angular displacement of the sun from the plane of the Earth's equator. It varies seasonally due to the tilt of the Earth on its axis of rotation and the rotation of the Earth around the sun. As you can see, the Earth is tilted about its axis by an angle of 23.45 degrees, and this causes the solar declination angle. It is denoted by delta, and the formula of solar declination angle is 23.45 into sine 284 plus n into 360 by 365. Here n is the day of the year. As you can see, solar declination angle is maximum at the summer solstice, while it is at the minimum at winter solstice. Zenith angle, theta z. It is the angle between the sun's rays and the perpendicular to the horizontal plane. So when the sun is in the overhead position, it is called zenith position. It is angle between the line that the point towards the sun and the vertical. So at sunrise and sunset, this angle is 90 degrees. Solar azimuth angle or gamma s. It is the angle made by the projection of beam radiation on the horizontal plane and the line due south, known as the solar azimuth angle. It is the angle on a horizontal plane between the line due south and the projection of the sun's rays on the horizontal plane. It is positive when measured from south towards the west. Surface azimuth angle. It is the angle made by the line due south and the projection of the normal to the inclined surface on the horizontal plane. As you can see in the figure, the line normal to the PV array surface with respect to the normal to the horizontal surface or the zenith, we can find the surface azimuth angle. Solar array tilt angle denoted by beta. It is also called the slope angle, and it is the angle between the inclined plane surface under consideration and the horizontal. It is positive for the surfaces sloping towards south and negative for surfaces sloping towards north. Angle of incidence, theta I. It is the angle between the normal to the inclined surface and the solar beam radiation falling on the inclined surface. The formula of theta I is mentioned here. Cos theta I is found out. Here 5 is the location, beta is the tilt angle, and gamma is the surface azimuth angle. Sunshine hour. It is calculated by N, and the number of daylight hours is denoted here. So N equals to 2 by 15 cos inverse of minus tan 5 into tan delta. Here again 1 hour is 15 degrees of rotation. This particular figure shows all the angles, that is gamma S, beta, theta Z, theta I, and gamma. The true zenith angle, the incidence angle, the solar altitude angle, the solar azimuth angle, the surface azimuth angle, and the PV array slope angle.